So on the left side, I have the Hicksian demand. On the right, the Walrasian demand. When are these two bundles identical? And here I'm going to say that when W is equal to the expenditure function required or associated with utility level U, then I know here that the bundle which is chosen at that level will be the same as the Hicksian demand, which is exactly the bundle that gets me to the same utility level. Let me now ask the following question. How does the Hicksian demand respond to a change in price? What's the partial derivative of the Hicksian demand with respect to price? If price is changing but utility remained constant, the expenditure is changing and therefore the wealth is changing. So here the wealth inside the Walrasian demand will change, will adjust, so the bundle remains exactly affordable. So I have both direct impact of the change in price, which is the partial derivative of the Walrasian demand with respect to price, plus the change in demand when wealth changes, and then the chain rule, the change in the expenditure when the price changes. Now here you'll recognize that the partial derivative of the expenditure function with respect to price, that's a Hicksian demand. How do we know that? That's from Hotelling's lemma, which we derived earlier with the envelope theorem. So here, this is the Hicksian demand. And we are in a situation, because W is equal to the cost associated with the cheapest, the least costly bundle to get to this utility U, the Hicksian demand is also equal to the Walrasian demand. It's the same bundle, right? And the bundle is not changing. So we can rewrite this expression. So I can write the Slutsky equation, which is that the change in the Hicksian demand when the price changes is equal to the change in the Walrasian demand holding wealth constant plus the change in the Walrasian demand that results from a wealth adjustment or an increase in your expenditure. Okay, this is the Slutsky equation. I can rewrite this in matrix form. Make this a little more formal looking. Now this expression you might be very familiar with, because if I rewrite, if I change the order of things a little bit, and I move this to the other side here, I'm going to get the following. The change in demand in response to a price change includes both a substitution effect, and an income effect. Now the expression here on the right hand side up here, you will recognize this. This is the Slutsky matrix that we've already derived before, but we've derived it very differently, right? So when we looked at the compensated price change, we were looking at the discrete change in price, and a wealth adjustment so that the original bundle remained just affordable, and we derived the Slutsky matrix. And if you remember, we have the property that warp in situations of compensated price changes was equivalent to the negative semi-definiteness of the Slutsky matrix. Now we find that the Slutsky matrix comes back again. We derived it slightly differently. We asked the question slightly differently. We looked at a situation where price is changing. It's an infinitesimal change, so it's a very small change. And we are keeping our utility level constant. So the response in the demand is identified here. That's the Slutsky matrix. But an interesting result that follows is that this Slutsky matrix is really equal to the partial derivative of the Hicksian demand. And this is a new result that is being introduced here. And in the next lab, I'll say more about that.